Hello. So I'm going to be making a small video series on how to get lights to flash, basically neopixels, a neopixel ring here to flash from a microphone. And so basically you talk, right? And the neopixel will flash or change colors or pulse or something, right? It'll basically be reactive. And this is for the Girls Who Code group in Wenatchee. So let's get started. Let's take a look at what we have here. So here's a NeoPixel ring we'll be using. Okay. Here's some jumpers to connect the NeoPixel ring. This is a microphone. This is a screwdriver to set the microphone sensitivity. This is jumpers to hook up the microphone. And this is the Arduino. So let's take a quick look at the Arduino here. I'm going to go to my desktop. So this is the Arduino program, the IDE, which you'll have to have installed. I can show you guys how to do that also. So let's look at the Arduino. So this is basically an exploded view. I'm going to zoom in just a little bit here. Okay, so on the Arduino Uno, we have where the USB plugs in, right? That's where it gets the power. You can also power it off of this. So you can power it off a lot of things, right? Which makes it really versatile. Okay, now these are the power pins. This is how things get power. We're going to go over some really basic electronics here. And these are the power pins. These pins right here can read analog voltage. That means it can read 0 to 5 volts. Okay? Some boards are 3.3 volts, and so they can only read 0 to 3.3, but this one's is a 5 volt board. So it can read 0 to 5 volts. We'll go over why that's important in a little bit. Now, these are just the general inputs outputs over here. So if I wanted to hook up a button or an LED or something, or hook up neopixels, I'd hook them up over here. Okay? So we've got power, analog pins, digital pins. Okay? So that's the basics of the Arduino here. Okay? I'm going to minimize that. And then let's look at our bench again. So what I'm going to do here is hook up the microphone. So if we look really closely, let's see, we have to the left, we have A0, which is analog, or A out, I guess. It looks like A0, but it's an O, not a 0. So A out, analog out. Okay, so that's an analog data. We have G, which means ground. Okay, we have the plus, which is for 5 volts. And then we have D out, digital out. Okay, and I'll show you how to set that in a little bit too. But first, let's hook that up. I'm going to take my jumper cables. It doesn't really matter like how you hook them up as long as they match on the Arduino. So I'm just going to plug them straight in here, all 4 of them. Okay, so there's all 4. And the A out, which is my purple one, I'm going to plug into A0 on my Arduino board. Let's see, there's a sideways view. Yeah. So A0 has that purple one. Next one is the gray one, which is ground. So I'll plug that into this ground over here. And the next one is the white, which is 5 volts. So white's going into 5 volts. Gray's going into ground. And the digital one, I guess I can hook it up over to 8. I'll hook it up over to 8 on the other side. Oh, 8. There we go. Cool. Just to give it something to hook up to. We might use it, we might not. We'll see. Okay. So your board should look something like this. Okay? And then you got the microphone here. So next thing I'm going to do, I'm going to plug my USB in on this board here. Okay? And I see I get lights all over the place. So I got lights on the Arduino. Right? Okay. You can see that one right there, right? That's my power light. And then a light on the microphone itself. Cool. Okay. So we got that set up. I'll leave this sort of a jumble there. And let's go to our Arduino here. Okay. So one thing we want to do is look at the data coming in from the Arduino. I guess I'll do a split here. Okay, so the Arduino can send data to the Arduino IDE. And I can do that with the serial command here. So under setup, right, everything you want to run under setup runs once. Okay, so everything from inside this curly bracket to this ending curly bracket or the brace, everything inside here will run a single time. That code will run once. And then we have loop here. Everything inside the loop, once it gets to the last line, it'll run again and again and again. So this runs infinitely. Okay, so I'm going to set up a serial link between the Arduino here and the computer. So I'm going to do capital S serial dot begin parentheses 9600. Okay. Now I use a capital, I use that period, I use parentheses, and I use a semicolon. That's called syntax. Okay. Syntax is very important. And if I didn't use that semicolon, if I just wrote begin a serial connection at 9600 baud, it wouldn't know what to do with that, right? It recognizes begin as a command, but it has nothing to do with this. You have to write it in a special way for it to actually function correctly. Okay? It does, even though us humans recognize this, the computer does not. The computer, we have to give very specific commands for it to work. Okay? So what this does is it uses a serial command. Okay? The serial command we're using is begin, and that creates a link, and it needs one variable. That variable is the speed of the serial connection, which is 9600. Okay? So that might be a little confusing. We'll go over how that works in just a second here. Okay? Next thing we're going to do is we're going to go to loop here, and we're going to create an integer, which is a variable. Right? So a variable is a piece of data that holds a value. That's basically it. So we're going to call this mic for microphone, right? Int mic equals analog read. This is a command to read one of these analog pins on the Arduino. And we plugged it into A0, right? So analog read 0. Okay? And then we're going to do another serial command. So serial.print ln. The ln makes it go to the next line. And I'll show you why that's important also in just a second. And we're going to print out whatever the value of mic is. Okay, and then we're going to do a delay. All delays are in milliseconds. So that's 100 milliseconds. That's 1/10 of a second. So let's take a look at our code here. This is the full code for our tester, okay? So serial.begin 9600, right? So we created a serial link from the Arduino to the computer at this data rate. And this is just a standard data rate. There's nothing super special or specific about this. But this is just a standard data rate. Okay, we created a variable called mic, and we're reading the value we're getting from the analog read 0 pin and storing it into the mic variable. Okay? Next thing we're doing is we're printing out, or we're sending it over serial, that variable called mic. And then we're waiting 1/10 of a second. Okay? And let's look back at the board here real fast. Okay, so we've got the microphone connected to A0 here and power and ground to the mic. And we're not looking at the digital out yet. We're just looking at the analog out. Okay? So let's give this a try here. I'm going to... Whoops, there I am. There it is. Okay. So to get it to upload to the Arduino, I have to do 3 things. Under tools here, I need the board, right? The board is an Arduino Uno. Okay, Arduino Uno. Okay. The port, it should show up as an Uno. Right? It says COM11 Arduino Uno. Yours might be COM3, COM4, COM7. It might not be the same COM, but it should say Arduino next to it. Okay. Last thing we do is the programmer, ABR ISP Mark II. Okay. So once we get those 3 things selected, right? Uno, port, programmer, we should be ready to upload. So there's 2 ways to upload. There's this arrow right here in the upper left, or I can go to sketch and hit upload. Same thing. I'm used to hitting the arrow, so I'm going to hit the arrow. It wants to know if I want to save it. And sure, I'll save this project. I'll call this, let's see, GHC, Girls Who Code, Wenatchee, mic test. Okay, I'll save that. Cool. And now it'll start uploading. You see how it says compiling sketch? So right now it's turning it into code, and now it's uploading, then it's done uploading. There we go. Okay, so we don't see anything yet. We see a light flashing on the Arduino, but that's about it. To actually check the data, we have to go to Tools and Serial Monitor. We can also hit this magnifying glass in the upper right. That'll also bring up Serial Monitor. Okay? And once we hit that, a little dialog should pop up with the serial monitor, and make sure that serial monitor is at 9600 baud. It's got to match. Okay. There we go. So now we're getting data from the microphone at 567. If I tap, I'm seeing some changes, right? Okay, that's pretty good. Those are some good changes. But what we want to see is where it sits, where the baseline is, right? And what I'm going to do here for a second is play some music and watch it move a little. Okay? Now, it might move a lot. It might not move much. We might have to adjust the sensitivity on this microphone. That's why you have this screwdriver here. Okay? I'm not actually liking how little it's changing, so we're going to need to up that. So I'm going to be quiet for just a second. We're going to watch the variables. So 567 is definitely the center of this noise here, okay? So keep that in mind, 567. Okay, now I'm going to play some music. So it's going down to 565, 571. So definitely not enough of a move. Okay, so I'm going to adjust the sensitivity of the microphone. I believe it's backwards. So here we go. Hey, check. Maybe it's forwards. Okay. I'll try adjusting it forwards. Just seems to be changing that. Hey, check. Okay. I know these things are like 50 spins altogether for changing it. We'll wait till that other LED on the board goes off. Oh, there it goes. So now as we tap it, we see that board or that light on the LED turning on and off, right? Let's see if I can angle that. There we go. So now as I tap it, but we're actually getting changes in our microphone here, right? In our serial data. Okay. So I'm going to be quiet again and look at where the center point is. 592 looks like the center point here, okay? But as we're talking into it, I'm going to hold it up to my mouth here. Let's see. I just have a bench face split. I don't have a desktop split. Okay. Well, we'll look at the desktop here. Hey, check. Hey. So I see it going down to 580 up to 600 and something, right? So I see the variables going up and down. Okay. So as I talk into it, microphones don't just put out a positive output, they put out a negative output. That's how sound works. Okay. So, whoops, there we go. Okay. So as I talk, it creates a waveform, right? So if I'm not saying anything, if it's silent, the waveform's just steady there in the middle. As I talk, it goes positive, negative, positive, negative. It keeps going up and down. What we're going to be looking for is that change away from the center point, right? So right now, center point's at 592, 593, about 592, okay? So let's take a look at the code here. Okay, so what I'm going to do is up top. This is going to be a global variable, so I'm going to call it int center point. I'll do a capital P here. Int capital P int center point equals 592. Okay. So this is the center of our talk, right? Okay. So now I'm going to get rid of this delay too. We need to see a lot of data here. So Mike equals analog read 0. So it needs the center points at 592. So it's 592. No, sorry. It's this minus 592. There we go. Okay. And now it should be about 0 and change variables based on where it is from 592. Let's take a look here. So a lot more data, right? But as we talk, I see the variables jumping a bunch, right? Okay, hey. Okay, so that's pretty good right there. Okay. So we're getting somewhere, but I don't like that it's floating around 2 and 3. It should be floating around 0. So I'm going to change that center point to, what would that be? Let's see, if it's minus 592 and it's not enough, it needs to be like 593, 594. We'll try that, 594. Now the reason it might have changed is because we're reading from it much faster, and so it might be, oh no, okay, hey. Oh, whoops, I see what I did. I wrote 592. I should have written center point. My bad. Capital P O I N T. There we go. I know how to spell. Okay. Let's see if that helps out at all. So I'm going to hit upload, and hopefully this floats around 0 now. Oh, it's floating around 2. I'm going to make this 596. Okay. Now let's check it. There we go. So now it's floating around 0. Perfect. Okay. Very good. Okay, so we got step 1 done now, right? We set up a microphone and we found the 0 point of the mic. So as you can see, as I'm talking, it's going from -1 to +1. If I were to pick the thing up and talk into it, it goes from big ranges, which is great. Okay. So this is the first video right here. The next video, I'm going to set up some NeoPixels, and then we're going to start getting them working together. Thanks for watching here.